The remainder of this course is going to be 2 back-to-back capstone projects, starting with this first one, which is a game called Tenzies. Now, let me be completely clear. Ask anybody in the field, and they will very frequently tell you that project building is the way to learn something new. There is no way to get better at React than to have your hands on the keyboard practicing React as much as possible. So although we won't necessarily be learning much new content in these remaining 2 sections, they do represent the most important parts of this entire course. Do not, under any circumstances, skip these capstone projects, or you will only be shorting your own education. Really, I don't mean to go on too big of a guilt trip, but this is where the real learning happens. If you're not familiar with the game of Tenzies, it's a game that's a little bit more geared towards children, as it deals with rolling a bunch of dice, the way that you play, and there's a GIF here that will kind of animate and show you how it works. You roll your dice, you try to get all 10 dice to have the same number on top. And so in our game, which we'll just move over here to the live version, I can click the dice that I want to hold. When I roll, it will roll all the dice except for the ones that I held. And let's see how lucky I can get here. We're just going with the 4s. There's another one. And this is usually where I start to get pretty unlucky in my rolls. Okay, there's one more. And okay, we have our last 4 here. What's really fun about this app, and you won't be able to see it here in the recording, but if you refresh here and play through the game, you'll see that when you click the last number and all the numbers are the same, then a really fun confetti drop starts from the top of the browser window. The button changes to new game, and clicking it will, of course, start a new game. Feel free to look through the code ahead of time if you kind of want to get a lay of the land and see all of the fun things that we're going to be working on. And keep in mind that this project is going to be one where I am simply giving you a challenge and then expecting you to work through the challenge, even if it stretches your capabilities and understanding a bit, and then we go through it together to make sure that we're on the same page. Well, what are we waiting for? Let's jump right into the first challenge. Here we are starting from an almost completely blank canvas. The only things that we have are our React and React DOM dependencies installed. Our index.html is bare bones, as it usually is in a React app, although I did include the Inter font from Google Fonts, so you don't have to worry about that. And our CSS is very sparse, just some very basic styles so that we can start from a good place. Hopefully this feels good to you. I know it's probably a little daunting. It's been a while since we have set up a React app completely from scratch, but that's exactly why we're doing it. So the challenge this time is just to start up a brand new React app. Some notes on how I'd like it structured. I want you to create a separate app component that will be in a separate file. Then here in the index.jsx file, I want you to import and render that app component. Inside the contents of the app component, just render a main element. It doesn't have to have anything inside of it, but then what you'll do is just style everything so that it looks like this very beginning state here where we have this blue background color and the main element, which is the white box here with the rounded corners. Click on the screenshot here to go directly to the Figma file where you can get all of the specific styles, including the colors and how much of a rounded corner there is and everything like that. All right, let's jump right in. Go ahead and spin up our brand new React app. If you had to go back to some of the earlier lessons and see how we scaffold a new app in React, believe me, it's completely okay. In fact, the recommended way of spinning up a new React app is by using Vite, and Vite will bootstrap all of this beginning stuff for you. So truly don't be fretting too much if you don't remember how to do these beginning lines of code. That said, we are going to go through this together. I need to import React DOM from React-DOM, and I'm going to call React DOM to create a new root element. And we have to tell it where that root is going to exist. So not a string. We need document.getElementById with the ID of root that's going to reach into our index.html and find the div with the ID of root right here. And this will serve as the root for our entire React app. Everything will get stuffed right here inside of this div. I'm just going to chain on top of the create root the render method. And I'm going to have it render the app component that I have not yet created. But for now, let's pretend we have created it. We'll import app from ./app, and let's go ahead and create that file, app.jsx. I honestly can't remember if I taught this earlier in the course, but whenever I'm creating a new file that is intended to be a React component, Best practice is to give a capital letter to the file name. So since app.jsx is going to export default function app, this is going to be my app component, I want to make sure that the file name starts with a capital letter. Okay, this app component just needs to return a main element for now. So that's what we'll put in. And just to make sure I can see it, let's go ahead and type something here. We'll cross our fingers and hit save. And oh, we got an error. Let's see, react_dom.createRoot is not a function. And yes, I missed this critical part here. This has to come from the client library in React DOM. Okay, good. Here we go. Type something here. Not too big of a bug. That's okay. Okay, let's spend the rest of our time doing some styling. I can see from the design file in Figma that I have this kind of dark blue background color. So I'll set background color to the dark blue that I see in the design. And then we will select our main element and give it the background color from the design as well. It's kind of like a whitish color. It's a little hard to see, but underneath type something here, we have that white box. Just to make it a little more visible, let me give it a height for now. We'll give it maybe, let's say 400 pixels just to start out. And I'll make my thing a little bit bigger here so we can see that bottom border. Let's actually start with 300. I'm going to be changing this in just a second, so this shouldn't be too big of a deal. And I need that blue border around everything. I think I'll accomplish that with some padding. Let's go ahead and give this some padding of 20 pixels. All right, we need a border radius for the rounded corners, so we will add a border radius of 5 pixels. And really quick, let's address the issue on mobile sizes. We see, first of all, this will just expand to as wide as we decide to go with our browser, and we hard-coded this height of 300 pixels on here. I think we can do a little bit better than this by adding some view height that allows the box to take up the entire view height, but we'll also do some max height stuff so that it doesn't get out of hand. Let me make this a little bit tall and just try to give this a height of 100 view height. And well, actually, we're able to scroll here. I think that has to do with our padding. Let's go ahead and move our 100 view height to the body. We'll add a height of 100% to the main element, and then I'm actually going to change the display of the body to flex. We'll use a flex direction of column. And then we actually have a layer between our body element and our main element. And that is a little bit tricky to find, but remember, we are stuffing our entire React app here inside of the div with the ID of root. And so we need to make sure that that div will fill its entire parent container. So I'm going to select the div with the ID of root and tell it that the height should be 100%. Okay, we don't get a scroll bar. Let's see if we make this bigger. Okay, we have that 20 pixel padding around everything, and the box is resizing accordingly. I think there's a point at which it's going to get way too big. And so on this main element, I'm going to give it a, let's put it right here. We'll call it a max height of, I don't know, let's say 400 pixels. Maybe we'll do the same thing for a max width. And then I think I will make this float in the middle. And actually, what I'm controlling here is the div with the ID of root. Let's see if this works. We'll just center everything. So I'll do justify content center and align items center. And this always kind of gets me. I think because we are going multiple levels down between the body and our main element, we just need to pass along some of these styles. So I need to make sure that my width is also 100%. And I think I need to do that same thing with my main element. And then we will actually move the max height and width to our div with the ID of root. And yeah, that looks like it might have done it. Our main element is a block level element, so it should already be taking up 100% width of its parent container. The only reason we had to add this to the div with the ID of root is because creating a flexbox for its parent changes the display for its child, the div with the ID of root. For any of you who are much better at CSS than I am, there might be a better way to do this. I would be happy to hear about it in the Discord, or you can reach out to me on X. But for now, I'm going to stick with this. I'm also going to just resize this browser so that we don't have to think too much about it. Let's go over to app and remove the type something here. Hit save, and it looks like we are in the same starting point that we're supposed to be in. And listen, I know that starting from a completely blank canvas can be a really challenging thing when you're first learning a new technology. So don't feel bad if you were feeling a bit stuck. It's also been a really long time in this course since we have started a new React app from scratch. So if that was a little bit of a struggle, that's completely okay. From here on, though, we are going to be having challenges that should be pretty doable for you at this point in the course. So take it as just another sanity check. If the upcoming challenges do represent too big of a challenge for you, it's not something to feel bad about, but it is a solid indication that you might need to go back and rework some of the practices and projects that we've done in the previous sections. So without further ado, let's jump in and start adding some more content to our Tenzies game. In this part of the challenge, we are going to create the dice that actually show up on the page. We're just going to have some hard-coded values for now. So other than simply creating a component, this is going to be a pretty CSS-heavy challenge. Because this is a capstone project, I am going to ask that you do the CSS. I know in the past I have said that we should just focus on React, but due to this project being intended to practice all of the skills that it takes to build new apps in React, I do want you to do the CSS for this. That said, once you're done getting these dice kind of in the center of the page like this, the rest of our CSS will be relatively simple in comparison. I've also tried to give you some hints in the challenge text, but we'll get there in just a second. Your challenge is to create a die component, and yes, die is the correct singular of dice. Unfortunately, it will make the rest of this project sound a little bit violent, but I promise I'm a benevolent actor here. This is going to be a fun project. Your die component should take a value prop where it will take in whatever value it's going to display on the dice as a number. And I don't know that I wrote it here, but it should render a button with that value displayed. Then for now, I want you to render 10 instances of this new die component. We'll just render it manually, so it'll be here actually 10 times, where you'll pass in a value to each one, where the value is somewhere between 1 and 6 inclusive. Then I want you to add the styling to the main element and the die components so that it looks like it does on the slide. As a hint, what I would recommend doing is creating a container around the 10 die components that you render, and using a display of grid to get them evenly spaced in the 2 rows with 5 columns like you see here in the picture. Speaking of the picture, just like in the other ones, you can click on this screenshot to take you directly to the Figma design file, so you can find things like the code for this drop shadow or the font size or whatever else you might need the design for. So I'd recommend making a container so that you can get your grid evenly spaced with the dice, and then turning the main element, which is what we have as this white background, into a flex box to make it easier to center up vertically and horizontally the container for your dice. I wrote both of those hints down here so you have access to them easily. All right, I know you've got this. Let's get started on this challenge. I'll start by creating a new file called die.jsx, a totally innocent version of die, and then we will export default our function die. We already know it's going to take props because, well, the challenge said for it to take props. It's going to have a value prop. And this should return a button because this is going to be clickable by our users. We want to make sure that we use the button element so that we get all the free accessibility stuff that comes with the button element. And what goes inside will be props.value. Props.value might seem like it's a little bit out of the blue, and that's because we haven't rendered any die components. Let's go ahead and see, I can get rid of this. We'll import die from ./die. I'm going to put this on its own line to start. And we will just have a presentational div. This is just going to be the container. Let's give it a class name and call it dice container. And inside, I can render 10 instances of my die component, and I'll just pass in a value of 1. It's also okay if you chose to pass it in as a string. I don't think it's going to matter too much for us at this point. And then I will just copy and paste this 10 times. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, one more, 10. And it's probably not going to be pretty, but let's go ahead and refresh. And sure enough, we get our 10 buttons on the page. Awesome. At this point, I think we will mostly be over in the CSS. So let's go over here. And I guess we're already here in the main element. So let's go ahead and change this to a display of flex. I'll give it a flex direction of column. And we will justify content center and align items to the center. Okay, nice. That got all of our buttons just right there in the center of the page. Let's go ahead and select our dice container, change this to a display of grid. And I'll be completely honest here, CSS Grid is not something that I have a ton of experience in, so I usually end up turning to ChatGPT to help me come up with the styles that I end up putting in my grid. Let's go ahead and change our grid template so that we have two auto-sized columns. So that's going to be auto-auto. And then we want 5 1 fraction unit rows. And so I can use repeat 5 times of 1 fraction unit. Awesome. We can give some spacing to this with a gap of 20 pixels. And now let's work on our buttons a little bit. So these will just be the buttons inside the dice container. So I'm just going to select it like this. And I'm just going to put down some of the CSS that I can find in the design. So we have a height of 50 pixels, a width of 50 pixels. There's a pretty cool box shadow in the design, so I can just copy the value that I found there. It's going to have a border radius of 10 pixels, and it looks like we get some interesting default borders from the button, so we'll just say border is none. The button kind of has its own color, and it's a little too similar to the background, so we'll give it a background color of pure white. And oh yeah, that makes it stand out a lot better. The font is pretty small. Let's give it a font size of, let's try 2 rems. Oh, that's really big. Let's try maybe 1.75. That's a little more manageable. Although I think we probably could bump up the font weight to bold. Oh yeah, that's looking great. Buttons automatically have the text as centered, but for whatever reason, buttons do not automatically have a cursor of pointer. So I'm going to add that. You won't be able to see this in the recording, but if you refresh the app and hover your mouse over each of these buttons, you'll get that familiar Mickey Mouse glove hand that indicates that it's clickable. We're rendering all ones right now. I think one thing I have found is that buttons don't tend to inherit the font family from any parent elements. Although honestly, I don't think we've set the font family here. I'll do that later. And we are going to be using the Inter font. And maybe we'll just include a sans serif as a backup. And actually, I said I'm going to do that later. I'm just going to copy and paste it right now. But we can see that if I didn't specifically put a font family on my buttons, then for some reason it doesn't inherit the font family from the parent. So we'll leave it in both places. While we're doing that, we should probably test all of the numbers so we're not just basing our decisions on all ones. I'll go ahead and include 2, 3, 4, 5, and 6 and hit save. And awesome, yeah, these are looking great. And I dare say that we probably are pretty close to the design, so I think we can call this one a win. Again, yes, that was a lot of CSS, but also again, this is fortunately the last of the major CSS challenges that we're going to have, at least in this project. Great work on this challenge. Next, what we'll do is get rid of our 10 hard-coded die components and more programmatically generate a random list of 10 numbers. So that's what's coming up next. When we're faced with a slightly bigger challenge, like generate 10 random dice components and display them to the screen, sometimes it can be a little bit overwhelming. A great practice to get into is to learn how to take those larger problems and break them down into smaller pieces so that you can solve each piece at a time. In fact, this is one of the key things that hiring managers and people giving tech interviews are looking for. They're looking for your ability to break down a problem into smaller pieces, solve those individual pieces, and put them together so that they create a solution to the entire problem. So we are going to break up this challenge of getting 10 random dice elements on the page into 2 parts. First, I just want you to write a function called allNewDice. And actually, you know what? I'm going to, on the fly, decide to call this generate all new dice. That returns an array of 10 random numbers between 1 to 6 inclusive. For now, you can just manually call this generate all new dice function and log the results to the console. As with any algorithmic challenge, there's more than one way to do this. If you need help learning how to create a random number in JavaScript, then a quick Google search or asking ChatGPT should be helpful to you. However, because we're inside of a learning environment here, I highly recommend you don't simply copy and paste this challenge text to ChatGPT and have it give you an answer. That is only going to short your own learning and take away a perfect opportunity to think critically and how to solve this problem. That said, I don't expect you to have memorized how to generate a random number in JavaScript. So just use your best judgment. Make sure that you're putting your effort into this so that you are not shorting your own education. All right, that's enough of that guilt trip. Go ahead and get started on this challenge. All right, let's write a function. Actually, I'm going to do this inside my app component. I'll create a function called generate all new dice. And even creating this function is something that we could break down into smaller parts. Let's say first we need to create a new array, and it'll just be empty. Then we need to loop 10 times since we're trying to create 10 numbers. And inside that loop, we're going to generate a random number between 1 and 6, and we will push that number to the array. And outside the loop, we will simply return the array. Okay, let's solve it this way, and then I think I'll show another way that you can solve this, just to show you that there's more than one way to solve these kinds of problems. We'll create a new array. Let's just call it new dice, and it'll be empty. We need to loop 10 times, so we'll just use a regular C-style for loop. I equals 0, I is less than 10, I plus plus. We'll say a random number is equal to, and we can use math.random, and actually we'll go math.floor, math.random. And if you're looking for a number between 0 and some other number, you can multiply this by 6 and then add 1, or we can simply say, let's do math.ceiling. Instead of rounding down, we're going to round up. And that way our lowest number will be a 1, and we won't have to add 1 in the end. So that's our random number, and then we will simply say new dice.push, the random number. And let me start clearing out some of these comments here. And then all we have to do is return the array of new dice. Let's go ahead and console log a call to generate all new dice and see what happens. Okay, let's open our console, and it looks like there's 10 numbers there. They're all between 1 and 6. Let's hit save again just to make sure. Yep, that one's good. That one's good. Okay, I think we're pretty safe that our function is working like we want. Can clean up the challenge text. Just for fun, I thought I would show another way that you can do this, and it's actually the solution I think I'm just going to leave here. So this was a very imperative way to do this. Another more functional programming approach would be for us to use some array methods. What I can do is simply return a new array. I don't tend to find myself using the new array constructor very often, unless I'm doing exactly what we're doing here. The array constructor can take how many items that array should have, and arrays have a method called .fill, where we can just fill every item in the array with something that we want. For example, some throwaway value like a 0. This by itself isn't super helpful, but we can now use a .map method to look at every item in the array and put our math.ceiling, math.random, I probably shouldn't have deleted this, times 6 code. So this will map over the new array with 10 items. And actually, let me show you this. So if I get rid of this map and hit save, we see we get our array with 10 zeros in it. That's what's happening in these first 2 lines of code. We map over that array and fill it. And for every item in it, we simply return a random number from 1 to 6. And okay, it looks like we are getting a working function once again. One way isn't necessarily better than the other. I don't know what the difference between the performance metrics would be in the way that we had it before and the way we have it now. I kind of like this functional programming approach, so I'm just going to leave it like this, but it truly doesn't matter that much. Okay, well, let's move on to the next part of this challenge, where instead of just generating a random array of numbers, we turn that into new die components. That way we can get rid of this manual die component repetition that we have here going on. We created a function where we can create an array of 10 random numbers, but next we need to find a way to move those 10 random numbers from just being here in memory in React to the page. Doing so requires us to create some state. So that's your challenge, to create some state that will hold our array of numbers. You can just initialize that state by calling our generate all new dice function. That way, when the app loads for the first time, it will call this generate all new dice function and just have those 10 random numbers ready to display. Then right here in the code, I'm actually going to put a comment here that says map over dice here. I want you to map over that array that's being held in state to create an array of die elements. This says elements, should say components, and then render those in place of our manually written 10 die elements here. Remember to pass a value into them so it can correctly display the number from the array in state. When you do this, you'll probably run into that warning about having to have a unique key prop for each one of your items. You can just ignore that warning for now. We're going to change things up in a little bit to fix that warning. Okay, you should be set with everything you need. Go ahead and work on this challenge. All right, let's go ahead and import use state from React. And just right here at the top of the function, we'll create some new state. Let's call it dice and set dice. And then just right here at the top of the component, we will create some new state. We'll call it dice and set dice is equal to use state. And we will initialize it with the array that comes back from our generate all new dice function. So we'll just give that a call. Then what we could do is just get rid of these 10 manual die components here, and we could do our map right here and say dice.map and kind of do the logic there. That's a completely legitimate way to do this. However, my personal preference is to create a separate variable inside the body of my function before the return where I can say something like dice elements, and it just feels like a little bit of a better separation of logic for me. I guess I'll just go ahead and render these dice elements since my cursor was already down there, and we can say dice.map, and for every number inside this array, I can render a die component where the value is that number. So this is where we can see if it works. The dice on the page currently read 1, 2, 3, 4, 5, 6, and then 4 ones. If I hit save, it looks like we, get a bunch of random numbers. Let's hit save again, and awesome, this is working great. Let's clean up some of our comments here just to keep things clean. And as I mentioned, we got this warning that says we need a unique key prop, and we'll be fixing this in the future when we change our array from being an array of just plain numbers into an array of objects. But that isn't quite what we're going to be working on next. The next thing we'll do is include a button that allows the user to re-roll the dice without having to refresh the whole application. The next challenge we have is to add a roll button so that when the user clicks the button, it will generate 10 new dice for us. Later down the line, we'll make it so that clicking individual dice will hold them and exempt them from the roll button. But for now, we'll just generate all 10 new dice. So the challenge is written out here, and you can add your new button down here. There's one little change that I wanted to point out, and that is that I've made a mistake on the font that I was supposed to be pulling in. I was pulling in the Inter font, and so I updated this to pull in the actual font from the design, which is Carla. And then I updated our CSS to use Carla instead of Inter. So sorry for anyone that was looking at the design and wondering what I was talking about with the Inter font. Okay, you should be equipped to work on this challenge, so I'll put in a pause now and give you a chance to add a roll button to our Tenzies app. Okay, let's start by adding our button first. And it's just going to say roll. It ain't going to be pretty, but let's refresh it. And okay, we have our roll button. And now let's hook it up to actually work. So I'll go ahead and add an on click on it that will call, let's see, what should we call the function? Probably roll dice. So we will need to make sure we create that function, roll dice. And it's going to update the dice on the page by updating state. And we have this set dice function. So that is all we're going to be doing inside this function of roll dice is calling set dice. And in our case, we currently don't care what the previous dice used to be because we're just generating 10 new dice. So I can just say generate all new dice. And this might be it other than some styling. Let's hit save, click roll, and yeah, look at that. All our dice are being regenerated. So let's go style our button just to make it look not quite so ugly. I'll probably first want to give it a class name. So let's give it a class name of maybe roll-dice, and we'll select it in our CSS. This will be the button with the class of roll dice. And it looks like in the design, we are sitting at about 50 pixels high and about 100 pixels wide. There's no border, but there is a border radius of about 6 pixels. I'll just grab the background color from the design, which is this kind of purple color there. The color of the text, though, needs to be white. The font size looks like it needs to be a little bit bigger. Maybe let's try something around 1.2 rems. Yeah, that looks pretty decent. And just like before, we did not bring in the font family because buttons don't inherit the font family. We can see if I add the font family of Carla, it does make a difference. Because we have both of those buttons, I think I might just have a button selector that uses that font family, and then I can remove it in these two places. And actually, while I'm at it, I'm going to move this cursor pointer up to my generic button selector, and that way, again, you won't be able to see it in the recording, but if you refresh it, you'll see we now have a cursor of pointer on all of our buttons here. And then the only other thing for now is to give it some spacing. We actually have a couple of other elements we're going to be adding to this page, like the title and a little instructional paragraph. So I think what I might do is, instead of manually adding I think the design shows about 25 pixels on the bottom, I'm going to come up to my main container, and instead of justifying the content to the center, I'm going to say space between. Oh, that is too much. There's one that we don't use quite as often called space evenly, and yeah, that one looks pretty good. We might be changing this later as we add more elements to the page, but that's okay. Just make sure our button is still working, and awesome. Whoa, this is an awesome Tenzies roll. Look at that, we have 5 threes all at once. That's great. We are not able to hold the dice quite yet. But as it turns out, that is the next challenge we're going to be doing. We need to make it so that when the user clicks the dice, it will hold that dice and exempt it from clicking the roll button so that only the unheld dice will get changed. Before we move directly into that though, I wanted to make sure that you are feeling comfortable with these exercises that we're doing. This challenge should have been a relatively straightforward challenge for you, assuming you were able to get through all of the previous challenges and the previous sections. As I've said before, if you found that this was a pretty difficult challenge for you, then I would recommend taking a pause, going back, redoing some of the previous challenges. Maybe you took a little break since you took those sections of this course. That's completely okay. But it is probably time to revisit those so that you can refresh yourself before just trying to force your way through the rest of this capstone project. If, on the other hand, you felt pretty comfortable with that challenge, awesome work, and let's move on to learning how we can hold the dice. The next challenge we're going to have is to make it so that the user can click on the dice to hold it, so that when they click the roll button, it won't change the dice that are being held. To do this, we need to have more information about each individual die than just its current value. Up until now, we've just been saving an array of bare numbers, but our challenge for this lesson is to update that array of numbers in state so that it becomes an array of objects instead. That way, each object can have a value property which will contain the same number that we were using before, but also additional information about whether that die is being held or not. And that's just going to be represented with a Boolean. When you make the change from having dice be an array of numbers to an array of objects, it will also break another part of our code. So make sure that while you're doing this, you update things so that we're back to a working state. All right, the time is yours to work on this challenge. Let's find the place in the code where we were originally adding just a bare number and change it to add an object instead, and that is this line right here. When we're mapping over our array of 10 numbers, instead of just putting a bare number in there, we can instead put an object in its place whose value is going to be what we had here before. And oh, I think I have my braces off a little bit right there. Okay, whose value, but also have an isHeld property, which we will default to false. Oh, and because we're using an arrow function, I need to surround my object with a set of parentheses just so that it doesn't think I'm beginning the body of the function like that. Let me go ahead and put these properties on their own lines just to clear up the spacing a little bit. And now let's try to think through the other places in our code that was expecting our state to have an array of numbers instead of an array of objects. And I can see one right here. We were mapping over our array of dice, and I chose to call this num because it was just a bare number. But now I'll go ahead and call this maybe a die object. And so the value should be die object.value now. I'm not seeing anywhere else that we would have any problems, so let's hit save. Let's click roll, and okay, we're back to a working state. Perfect. In an upcoming challenge, we of course are going to make it so the user can click on these buttons and hold them in place, which effectively would mean that we find that specific die in the array and flip its isHeld value. But before we move on, I want to address each child in the list should have a unique key prop warning that we've been getting. Remember, when we map over an array and we create an array of JSX elements, React needs a prop that's dedicated to JSX elements called key so that it can keep track of items every time something gets re-rendered. And it's crucial that that key be unique to this specific die. Now, of course, we couldn't use die object.value as the key because the whole purpose of this game is to get all of them to have the same value. Very often, you'll find yourself mapping over an array of data that gets pulled down from an API, and more often than not, that data includes some kind of ID that was generated by the database that's holding that data. And if you have something like that, then perfect. That's definitely what you should use as your key because it's pretty much guaranteed to be unique to that object. In our case, though, we're generating our data right here. And so we need a way that we can add an ID property to our dice so that, first of all, we can add it as the key prop here so that React knows how to distinguish this individual die component from other die components in this array. But it's also going to end up being pretty helpful for us when it comes time to hold the dice. So one thing that I can do is use a third-party package. There's a really simple one that's called nanoid. So I'm just adding that to my list of dependencies. I can import nanoid from the package nanoid, and this will generate a unique ID number for me by simply calling nanoid like this. I'll hit save, and we'll see that, oh, of course, we are still using dieObject.value as our key. We need dieObject.id as our key, and okay, awesome. Now our warning goes away. Okay, so our data is primed so that each individual die component has a way to know if it's held or not, but of course, we don't yet have a way for the user to change that. So that's what we'll be doing in the next challenge. Very soon, we're going to add the capability for the user to click the die so that it will be held. But unless we add some special styling for dice that are being held, it's going to be a little bit difficult to test this out. So the first thing that we'll do is style our held dice, or in other words, the dice who have an isHeld property to true, so that when they are being held, they will have this kind of light green background color. The way that we'll test this in this lesson is I'm just going to change the isHeld property to true for all the dice. So when you have successfully completed this challenge, all of them should turn that light green background color. So that's what your challenge is. I need you to add conditional styling to the die component over in die.jsx so that if it's held, or in other words, if isHeld is equal to true, its background color changes to this light green color, which I've given you the hex value for right here. There's different ways that you can handle this conditional styling. I'm going to leave it up to you to decide which one you want. And remember, currently the die component doesn't yet know if it's being held or not. And I'm going to leave it a little bit vague like that, so you'll have a chance to figure out what that means and how to fix it. Go ahead and get started on this challenge. The first thing I need to do is to make sure that I am teaching the die component how to know if it's held or not. Currently, we are only passing a value down to our die component. And so I'm going to put this on its own line to buy myself a little bit of room here and pass in the isHeld prop, or I should say a prop that I'm choosing to call isHeld because it happens to be the name of the property in the object. So the value will be dieObject.isHeld. In that way, each of the die components will know through props if it's held or not. Now, at this point, what I could do is either conditionally render a class name, as in the class name could look at props.isHeld and either apply the green background color or not by adding or removing this class name. But I think what I'm going to do is just use an inline style. So in my button, I'll say style equals, and then I could either pass my styles directly here, or something I tend to like to do is to add a separate object up here and pass in the styles directly. Remember, these styles are accessing the native DOM properties. And so when I want to change the background color, especially because I'm here in an object, I can't as easily use background-color without surrounding it with a set of quotation marks. Instead, I need to use the capital C color, or the camel-cased version of this property. And I can use a ternary that says, let's look at props.isHeld. And if it's true, then I want the background color to be that green color that we see right here. So let me copy that and we'll paste it in there. We'll just set the color to white, which is what it is in the CSS. All right, I think we might be all set up. Let's hit save, and sure enough, look at that. We get all green colors, and that's because we had changed this from false to true. If I change it to false, then we can see that it all turns white again. Okay, now we are ready to tackle the challenge of holding each die whenever it gets clicked. We talked previously in our section about state about a concept called derived state. And generally speaking, we found that it's better to have a single source of truth where the state is held on the parent. Well, it turns out our Tenzies game is a perfect example of this. It might be tempting when you're first starting to write React to say, well, I want each dice to be able to know if it is currently being held or not. And so you might go to your die component and add new state to it that says bring in the incoming prop of is held, and then set internal state that can be used to display whether the die is being held or not. And then you would create a function inside of the die component that when the die component is clicked, it would flip that internal state for that one single die. However, as it turns out, if we're looking forward to the mechanics of our game, we can only know if the user has won the game if all of the dice are being held and if all the dice have the same value. But if each die component were in charge of flipping its own state, it would become out of sync with the state that's being held in the parent. In other words, when we first load our component, this first die that has the value of is held of true gets passed down to the die component. But if the user clicks it and flips it to false, that doesn't change the parent state where it says is held as true. And so hopefully you can see that that would become a problem. So although it does tend to be a little bit more code, a more correct approach that does not rely on using derived state would be to get rid of the state from the die components, keep the state that is currently in our app, and create a parent hold function that we pass down to each one of our die components. This hold function would take an ID so that when one of the dice is clicked, it would call the hold function, pass to it the ID of itself, and the parent state would be able to loop over the array of dice objects, find the one with the ID that was called in the hold function, and simply flip the is held property of that one die. That was a lot of talking. I hope this diagram helped visualize what I'm talking about. And so the first part of this new feature is what we are going to be working on now. I want you to create a function that's just called hold, and it will take an ID as a parameter. For now, all the function has to do is console log the ID. Then I want you to figure out how you're going to pass this hold function down to each instance of the die component so that when each one is clicked, it will log its own unique ID property. And I did mention here that there's more than one way to make this work, so just feel free to choose whichever one you want. In the end, because each one has a unique ID, the way that you will tell if it worked is if by clicking this first button, it will display one ID, and then clicking another button will display a different ID. We're starting to creep up on a little bit more difficult challenges here, but I know that you've got it in you to get this done, so go ahead and get started on this challenge. Okay, let's get started. I think I'll put my function just down here below roll dice, and we'll say this is hold. It's going to take an ID as a parameter and simply console log that ID. Well, now what we need to do is figure out how we can pass this hold function down to our components. Let me clean this up to buy some room. And clearly, in order for each die component to have access to this function, we need to pass it down through props. I'm going to put each of these properties on their own lines just to, again, buy some room. And we'll go ahead and pass the hold function, just like this, down to our die components. However, we hit kind of a blocker at this point. Remember, when we go over to our die, we're receiving props.hold now, and I can simply add to my button, let's see, right here maybe. Let me put this on its own line too. Right here, we can say on click, it's going to call props.hold. Here's where the problem begins, and I wouldn't be surprised if some of you doing this challenge ran into this issue. If I go ahead and click 4, we'll see that I don't get an ID, I get something that says synthetic base event. If I click another one, they're just all saying synthetic base event. I'm going to put another pause in here and see if you can figure out what's going on here. Remember, these on-click events, the function that you pass to it, we don't get to decide what parameter it receives. It will always receive an event object. So we need to think back, how can we provide our own parameter if we want to call a function? Well, instead of just passing props.hold as the function that gets called when onClick happens, we can instead kind of wrap that in a function that says this is the function you should run when the onClick for this button happens, and this function will call props.hold. And at this point, I can put in whatever parameter I want. Well, we run into another problem. I don't have access to the ID here in my component. So simply enough, what I could do is just come down here once again and also pass my ID property. So this would be dieObject.id. Once again, this ID is coming in clutch for us. And over in the die component, I'm now receiving props.id, so I can pass that in right here, props.id. Let's try this again. I hit the 4, and there's a crazy looking ID that was generated by NanoID. We'll click 5, and sure enough, a completely unique different ID. Just for giggles, I had mentioned that there's more than one way to do this, and so I figured I'd give you a chance to see what that might look like. There might be more than just these two ways, obviously. But here, what I can do when I'm passing down my hold function, instead of just passing down the hold function as a whole, I can do essentially what I did in my onClick and say, I'm going to pass down this unique function, and this will end up being a closure that captures the ID value that I passed to this parameter right here. And so in that case, I don't even need to pass my ID down. And when I'm receiving it, I don't need to do this anymore because props.hold is now a closed function that already contains the ID of this specific die component. I think the way that we had it before might be a little bit more intuitive, but because this is working and just for the sake of seeing a different way to do something, I'm going to leave it like this. Okay, we're making good progress. Next, we need to make it so that we're not just console logging the ID when the user clicks the button, but instead we are updating the isHeld property on the correct die in the array. Let's make it so that users can click the die, and instead of it obviously console logging the ID, it will change its isHeld property to true. Or if it's already true, it'll change it back to false. You'll know that you've succeeded in this challenge if clicking a die will change it to green, since we have already set that up over in the die component. However, keep in mind that we haven't yet implemented the feature where clicking roll will only change the dice that have not been held. And as a hint, although this is more like a reminder because I've said it before, that there's more than one way to accomplish this. So don't spin your wheels too much trying to make sure you get it exactly the same way that I'm about to do it. If clicking the dice changes it from white to green or green to white, then that's how you'll know you've succeeded. This will be one of the more difficult challenges that we have throughout this whole section. But fortunately for you, we've actually done something nearly identical to this in the past when we learned about state using this little sound pads exercise. You can click the screenshot here to go back to that exercise if you need a refresher on what we ended up doing so that we could flip these on and off. So you should be prepped now to have everything you need to work on this challenge. All right, I'm going to buy some room by getting rid of the challenge text since I know what we need to do. Instead of console logging the ID, we need to update our state. Because we're holding our state in one unified place here in the parent component to all the die components, we can simply call setDice. And our task is going to be a little bit more complex because we have a whole array of dice that we're looking at, and we only need to change the isHeld property of one of those dice. As such, I do need to know what my old dice were, so I'm going to use a callback function. And I think for the sake of clarity to start this out, I'm going to open the body of this function and use an actual return keyword here. Remember, dice is an array of objects, and so what I need to return when I'm calling setDice is another array of objects. And I can get a new array by calling oldDice.map, and I will look at each one of the dice, or each die, in the array of dice. And the most important thing for me at this point is to check if this die has the same ID as the one that was clicked, or the same ID that we're receiving as a parameter to our hold function. So I could do an if statement and check if die.id is equal to ID, or I can just use a ternary, which will allow me to be a little more concise. I'm going to return and then first check if die.id equals the ID. And if it does, then what I want to return is a new object, and it will contain all of the properties from the original die, but the isHeld property is going to be the opposite of die.isHeld. If the IDs don't match, that will be my else section in my ternary operation here. I can simply return the old version of the die. I don't need to change it whatsoever. Okay, first let's check to see if we are working. I'll hit save, and boy, that is a terrible Tenzies roll. I don't know if I've seen one that bad in a long time. I guess we have 3 6s. Oh, no, it's not. And oh, look at that. We have 4 6s. Oh, awesome. Clicking them makes them green. Awesome. As I said, if we didn't want to hold them, I could click them again and they would flip to the opposite of is held. So we get to go back and forth. And as I mentioned, clicking roll is just going to refresh them completely. We don't save any of the dice, which is fine. That's what we're going to be working on next. Well, let me come back to my code and do a quick refactor. I mentioned using an explicit return like this, but because I'm using arrow functions, I can rely on implicit returns. So let me pull this up to its own line. And boy, this is going to get a little confusing. Okay, I've gotten rid of that explicit return. Here I am mapping and using another arrow function. So I think I can do another implicit return. I might have to open some parentheses. Let's get rid of our curly braces and let's see. Actually, I don't think I need that one. And I don't like the spacing of this. Let's see. Okay, that makes... And okay, yeah, that works. I don't know that it's really that much easier to read, but I guess it saves us a couple lines of code. Whatever. Let's just hit save to make sure this is still working. And let's see, we have 3 2s. Perfect. Or maybe we change our mind and we select the 4s. Great work. Okay, the next big feature we have is to make it so that when we click the roll button, we don't lose our held dice, but only re-roll the dice that are not being held. So that's what's coming up next. Other than checking if the user has won the game, I think this is the last major feature that we have to add to our Tenzies game. Your challenge this time is to update our roll dice function so that instead of generating all new dice every time the button is clicked, it will look through the existing dice in the array and only roll the ones that are not being held. As a hint, this is going to look really similar to the hold function. I guess we didn't call it hold dice, we called it hold. And it's helpful to remember that what we mean when we say you're rolling a die, really you're just going to be updating the value property of that die object. I'm not going to get any more detailed than that. I want you to figure out how to finish this challenge. So the time is yours. Go ahead and refactor our roll dice function. We know that we're going to be updating our state, so we do still need set dice here, but instead of generating all new dice, we are going to look at the old dice array and we'll map over it, checking each die along the way if it is being held. So we'll use this arrow function and we will map over old dice. And for each die in the array, I'm going to check if die.isHeld is true. I'll just use a ternary here. And if the isHeld property of this particular die is true, then I don't want to change anything. I just want to return the same die object. Otherwise, I'm going to return a new object that has all the same properties of the original die. This is important because it allows us to keep our ID that we generated when we first created the dice objects. But I want to change the value property to be a new random number, which I can just get by calling this code up here. Let's go ahead and I think we have it right. Let's get rid of this challenge text, hit save, and we got a good amount of 2s here. All right, moment of truth. We'll hit roll, and look at that. All the dice except for the ones being held rolled. So I can play through the rest of this game holding the dice as I go. And we're getting pretty lucky so far. There we go. All right, well, this brings us to the beginning of the last feature, and that is that we need to be able to indicate to the user that they have completed the game. As it stands right now, if I click this 2, they're all green, and I know personally that that means I've achieved Tenzies, but I can still hit roll. There's no way for me to reset this game other than to refresh the page. And maybe most importantly, there is a critical lack of confetti dropping down from the page. All of those are things we are going to be working through as challenges. But before I do that, speaking of indicating some information to the user, I am just going to paste in some of the elements. You can see from the design, we have a header and a little paragraph that instructs the user how to play the game. So those are not really worthy of a challenge at this point. I'm just going to paste in some of that markup. as well as provide a few styles here. Let's see, I'll just put it right here below the main, and we'll just paste those in right there. Let's hit save. And well, I think I want a little bit more space above my button or below the dice container. So let's see, where are we? Right here on our dice container. Let's just put a margin bottom, maybe 40 pixels. Okay, yeah, that's looking pretty good. Great work on getting this challenge done and all of the challenges in this feature. We're now able to hold the dice and continue rolling the ones that are not held, which is essentially the crux of playing Tenzies. As always, feel free to play around with this code as much as you want. Make sure that you understand it before just plowing ahead. Once you're ready, we will move on and start implementing some of the logic for what happens when the game is over. Okay, guys, I have a confession to make, and that is that this is not the first time I have taught this course using this project, the Tenzies project. In the previous version of this React course, I also went through pretty much all of these same things with the Tenzies game. However, as I was reviewing some of the things that I taught back then, I realized that I made a mistake. And so I wanted to make sure that I got it right this time and that I gave you a chance to think critically, because what we're about to cover is a mistake that not only I made in the past, but one that I see very often in the React community, especially with beginners in React. And so we're going to take a little break from writing code and we're going to put on our critical thinking hats. Our goal is to indicate to the user that the game is over if, first of all the dice are being held, and second of all, if all the dice have the same value. If those two conditions are true, then we can consider the game as being over and won. So let's start planning ahead and think how we might accomplish this. Some questions that we can consider would be, first of all, do we need to save a game1 value in state somewhere? If you think the answer is yes, then why? And if you think the answer is no, then why not? And secondly, do we need to create a side effect with React.useEffect to synchronize this game1 value, whether it's being held in state or not, with the current state of the dice? These two questions are meant to guide you in your planning session here as we decide how we're going to implement this feature. So I'm going to put it on pause here. Just like when we've taken quizzes in the past, I want you to type your answer into the comments here, both for number 1 and number 2. And then I want you to have a conclusion section where you write out a simple plan of how you're going to implement this feature. So I'll go ahead and put in a pause here. Don't skip this step. This is a crucial thing for you to get practice with as you're learning. Take some time now to answer these questions. What I taught in the previous iteration of this course and this part of the challenge was I created new state, and I said, we're going to have a variable, a state variable called Tenzies, and we'll call set Tenzies. The reason I chose Tenzies is because in the real game, you're supposed to shout Tenzies when you have gotten all of it. It's really a race against other people. And so that was equal to useState, and we set the initial value as false. And then I also created a side effect that watched for any time the dice state changed, and then checked for conditions to see if Tenzies was true. In other words, if all the dice are held and all the dice have the same value. And as I'm sure you have guessed by now, I realize now that this was not the correct way to do this. So if we're looking at the answers to these, do we need to save a game1 value in state? Well, as it turns out, the answer is no. Remember how React will re-render our component every time the state changes? Part of re-rendering the component doesn't just mean it updates what's on the page, but it means that it reruns all of the code inside of our function. So instead of setting a new state variable, all I need to do is derive the value of whether the game is won or not based on the current value of dice. In fact, this setDice function is the only state setter in our code that's going to cause a re-render anyway. Instead of creating new state, I can simply use the state that already exists with dice, and every time the component re-renders, I can check again to see if the game1 conditions have been met. I'm not going to write this code because we are going to do that in the next lesson, but I will write a comment that simply says, check if the game is won. And I can do this on the top level of my app component. This code will run after every single re-render. In other words, every time the dice get set to something different. And I can use this variable that I create, if the game is 1, to add whatever features I want to add, change the text of the button, or make the confetti fall down. If instead I were to save the game 1 value in state, then I would need to include a side effect so that I could synchronize the dice state with the game 1 state. And so question number 2 definitely would depend on what your answer to question number 1 was. If you answered yes, then you would likely need a side effect so that you could synchronize those two pieces of state. But since we answered no, we don't need a side effect. So we can, again, say no, we don't need a side effect. I think when we write the code for these features, we'll get to see exactly why we won't need these things, and we can keep it as simple as possible. So our conclusion is that we can derive the game 1 status based on the condition, or we'll say conditions, of the current dice state. Because of this, we can calculate whether the game has been won on every single render just in regular code here at the top level of my component. And so maybe to be more specific, I'll just say on every render. As I mentioned, this is a really common pitfall in React. In fact, so much so that there's a dedicated article in the React docs that's dedicated to teaching you that you might not need an effect. So many developers in the early days of the useEffect API were misusing it that the team had to put together a whole tutorial to teach people to stop using side effects when it isn't necessary. Specifically, it says that they are meant to be an escape hatch from the React paradigm. They let you step outside of React and synchronize your components with some external system. In our case, we're not trying to synchronize with an external system. We're just trying to derive a value based on our current state. I hope that makes sense. I know that's a bit theoretical, but again, I think you'll see just how easy it is to add this new feature where we can determine if the game has been won without having to deal with state, without having to deal with side effects. So without further ado, let's jump in and get our hands back on the keyboard so we can start typing some more code. We'll do this in a series of smaller challenges. The first thing I want you to do is simply to log game 1 to the console only if the two winning conditions are met, which I've outlined here and we've talked about before. For now, you don't even need to save a variable. You can simply put a conditional right here at the top level of our component. Go ahead and get started on this challenge. The tricky one with this challenge has more to do with getting these winning conditions right than it does pretty much anything else. We can simply have an if condition that if it evaluates to true, will console log the game is won. And so the trick is simply making sure that we get these conditions correct. And there's a lot of ways to determine if all the dice are being held and if all the dice have the same value. I'm going to make use of an array method called .every. It lets you pass in a callback function, and if that callback function returns true for every item in the array, then the entire expression evaluates to true. So for example, I can say if dice.every, and we're going to look at each die in the array and say if die.isHeld, then return true, or in this case, it's simply going to return the value of die.isHeld, which means if every die is currently being held, then this entire expression will just evaluate to the Boolean true. Whereas the .map array method returns a new array, .every simply returns a Boolean. Okay, so there is one expression. We also want to check if every dice has the same value. Well, if every dice has the same value, I could just arbitrarily choose one of the dice, get its value, and check if every item in that array has the same value as the first die. I'm going to put this on its own lines, I think, just to maybe space this out a little more easily. And we'll say if dice.every, not dive.every, dice.every. We'll look at each die, and we could say if the current die's value is equal to the very first dice in the array, so dice at the index of 0 dot value, then that means that every dice has the same value. So let's get rid of our challenge text. Let's hit save. We should not get game 1 because our winning conditions are not true yet. And I guess we need to play through this game. 3s look like a good start. And whoa, look at that. 4 more 3s in one roll. That's crazy. And okay, here we go. So when I click this, we should get game 1 in the console. Perfect. Okay, now that we've been able to figure out the logic for our winning condition, let's go ahead and do a second part to this challenge. Okay, for challenge part number 2, I want you to create a new game1 variable, and I'll leave it up to you to determine what its value should be. It should be pretty straightforward since we just wrote the logic for it. And also, if game1 is true, I want you to change the button text so that it says new game instead of roll. This by itself won't make the new game feature actually work. That's something we're going to do in a couple challenges from now, but it'll be one step closer. All right, I'll hand it over to you. Well, we don't need to check the conditional or run any code at this point, but we do want the values that are being held inside of our conditional. So I'm just going to cut those out and delete here. We'll create a game1 variable, and that's just going to equal whatever the Boolean value is from these expressions. And remember, what we're doing here is deriving the game1 value based on the current state of the dice array, which means every time the dice array changes, or in other words, any action that we take that might call set dice, our component will re-render, the entire app function will run again, and we will get an updated version of game1. Of course, it's just a Boolean, so it'll be false most of the time you're playing the game until the very last click, but I think you get the idea. Okay, for number 2, let's change the text of the button based on this game1 variable. We can get rid of the challenge text, and we will, let's see, right here, I'm just going to put roll on its own line so that we can, instead of hard-coding roll, use a ternary. We'll say if game1, then we want it to say new game, but otherwise it'll say roll. Okay, I'll hit save, and I'm going to play through this game. I'll skip ahead so you don't have to watch it. Okay, moment of truth. I'm going to hold the 2, and sure enough, that changed to new game. I don't actually love that it is wrapping like that. Let me come to the button in CSS, and I think it's this one. We'll change the width to 150. Yeah, that looks a little better. Actually, you know what? I think instead of hard coding this as 150, I think that's going to look a little bit wide when the text just says roll. I'm actually going to allow this to adjust the width based on the text that's in there. So I can say white space should be no wrap. I don't want the text to wrap. Then I can set the width, I believe, to auto. And at that point, I probably want to make sure I give some padding to this. And I just referenced the design. It looks like we can say we're about 6 pixels on the top and bottom and 21 pixels on the left and right. Okay, so if I hit save, I guess I have to go to one of these to hit save. The button resized and it still has some decent padding. I think that's a little better. All right, I think the next challenge is going to be by far the funnest challenge that we have in this entire project. And that is to make it so that when the game gets won, we get the awesome confetti drop in our app. So let's jump into that one next. This one is definitely the most fun challenge in this entire project, and that is to make the confetti drop when the game is won. There's a really fun package called React Confetti, and it couldn't be simpler to use. I've already installed it in our project. You can click on the screenshot here to go to its GitHub repository and read through the use section. It will recommend including a width and height prop, but for now we can just ignore that. It will default to the window size. They recommend doing that because if you resize the window, then your confetti will be the wrong size. I guess that could be a challenge that you do based on the work we did with side effects in section 4. But for now, again, just ignore the height and width props. I've already installed the project in our dependencies, and there is one major caveat. At the time of recording this, because React 19 has not officially been launched, and we've been using the release candidate version for this course, React Confetti doesn't quite yet work on the release candidate of React 19, so I did have to downgrade to React version 18.3.1, which is the most recent stable version of React. React 19 has been on the very precipice of being released for a number of months now, so by the time you're watching this, I wouldn't be surprised if React Confetti works just fine on the official release of React 19. But for now, we're going to deal with it this way. Oh, and I almost forgot, I have a fun GIF that shows you exactly what will happen when you have won the game. The confetti will drop, our text will change to new game, like we did in the last section. That button won't quite work yet. But like I said, this is the most fun challenge for sure. Okay, your turn. Get started on this challenge. Okay, we can see from the documentation that what we need to do is import the confetti component, and it's just a default export from the package, so we'll import it from React Confetti. We have our game1 variable here, which is what we will use to conditionally render the confetti component. So we'll say game1 and then render the confetti component. Like I said, it pretty much couldn't be simpler. Let's get rid of this challenge text, hit save, and I'll fast forward through this so that it's a winning game. Okay, one downside of the way that the recordings work here on Scrimba is that any elements that are displayed on the canvas of our web browser don't actually get recorded into the scrim. And the confetti is using the canvas to create all of the colorful confetti shapes. So I'm going to click 3 here, and sure enough, I can see the confetti dropping. And I'm sure that you did this challenge and succeeded in it and were able to see the confetti drop on your end as well. At this point, in order to start a new game, the user would have to refresh our page. So let's go ahead and implement the logic we need so that the new game button works, and I believe that will wrap up the last feature that we need to add to our Tenzies game. You know what? I changed my mind. There is one more topic I want to touch on that's a little more boring than actually implementing the new game functionality. So we're going to get this one over with first, so that we can end on a high note of adding the last feature to our game. What we're going to be talking about has to do with this line of code here on line 7, where we're initializing our state. We're calling useState, and then we're giving it an initial value, but the way that we're giving it an initial value is by calling a function. And at first glance, this might seem like it's fine. This is the initialization of the state, right? So it's only going to run this line of code one time and then handle any changes to that state behind the scenes. Well, let's remember that every time we make any kind of state change in our app, like when we click a button to hold it or click the roll button, we are changing state in our component, which means that React is going to rerun all of the code inside of this function. And part of running this whole function includes calling this generate all new dice function. Because React is handling the state behind the scenes, it's not going to update the state per se just because we called this. But it really is calling this function on every state change, and I can demonstrate that by adding a console log to generate all new dice. Let's say generate all new dice was called. Okay, let me hit save. That'll refresh the app, and we can see that we get it one time, which is what we would expect. But when wow, look at that, we have 6 sixes. Every single time I hold one of these dice, it's also calling generate all new dice again. Now, the code inside the generate all new dice function is not that intensive. It's doing a few things. It's mapping over an array with 10 items, which JavaScript can do extremely fast. For each one of those items, it is calling this nanoID function, which I imagine is not very expensive, even if you're doing it 10 times. But then in the end, React is just discarding everything that is returned from this array after the first time it runs it, because it knows it doesn't want to reset the state. So how can we address this issue? Well, fortunately, React made it really easy. When we're initializing our state, we can provide a regular value for the initial state like we're doing here. It might not look like a regular value, but since we're calling this function and that's returning the array, that's pretty much equivalent to providing just a bare value. Alternatively, we can provide a function for React to run, and then that function needs to return the value that we want to use as the initial state. By doing this, React will make sure that it does not rerun this function on the subsequent re-renders of our component. So I still have my console log here inside of the generate all new dice function, but if I hit save, we get it once for the first time, but then as I'm holding dice and clicking roll and changing state otherwise, our component is re-rendering, but it is not rerunning our generate all new dice function again. Again, in this case, the performance benefit is a little bit underwhelming, but if you were doing a more expensive operation in order to initialize your state, this would be a perfect way to ensure that you only have to do that one time. Let's clean up this console log and we can close our console. And now, as promised, we'll move on and make it so that the new game button actually starts the game over from scratch so the user can play again. This is another example of a challenge that I'm going to be pretty vague about and just give you more of a Scrum-style user story and leave it up to you, the developer, to figure out what needs to happen in the code to accomplish the task. The task at hand is to allow the user to play a new game when the new game button is clicked. And I guess it's probably redundant to say, and they've already won. The new game button currently will only show up if they've won the game. And actually, that's all I'm going to say about the challenge. So I'll hand it over to you to work on adding this feature. Well, so far, all I've done with this button is conditionally render the text depending on the value of game one. But of course, this onClick is always going to call roll dice, whether the text says new game or it says roll. One approach I could take is to conditionally render a button that says roll that calls roll dice if game one is false, and otherwise render a completely different button with a completely different function that it calls if the game is won. However, to me, that feels like a bit of extra work that I don't really need to do. Instead, what I could do is simply update the logic for my roll dice function so that it checks if game is won, and if it is, then it will do one thing, and if it isn't yet won, then it will do another thing. So let's come up to our roll dice function. And the code that we have here is code that I really only want it to run if the game is not won. So if not game one, then I'll move this code inside of this conditional. But now I can add an else, which means that the game is won, where I can just set the dice to be all new dice. And fortunately, I created a function called generate all new dice. When I generate all new dice, it will reset all of them to an isHeld of false, which means that our value for game one should now be false, and the confetti will stop playing, all the green will go away, and the numbers should be shuffled again. Let's go ahead and hit save. I'll spare you watching me run through this game by skipping ahead. Okay, I'll click the last 6. I'm seeing the confetti on my end. And now the moment of truth, if I click new game, awesome, everything starts over from the beginning state. I can see an argument to be made that we are kind of overloading this function, and it might be better to conditionally render a second button, but I think for now I am probably just going to leave things the way that they are here. At this point, all of the features of my app have been added. However, there is one crucial thing that I've neglected to do. Because we have a highly interactive app here, especially when you're dealing with games, there is a lot to consider when it comes to making sure that your app is accessible for those using assistive technologies. In an effort to keep us laser focused on practicing React-specific things, we haven't yet touched on those, but I would definitely be doing a disservice if we didn't include them in our app. So in the next lesson, I'll walk through a few of the accessibility changes that we need to make to our app so that it is usable by everyone. Because we chose to use a button element for our die components, we get a lot of accessibility benefits for free just from HTML. In general, for accessibility purposes, it's important for clickable items to usually either be a button or an anchor, like a link leading to another page. Otherwise, you have to start considering using tab index to make sure that it's accessible via the keyboard and setting the role as a button and all sorts of things. So using a button here was already an accessibility win. That said, because the information in the button simply has a number in it, we can improve how assistive technologies announce the buttons by adding an ARIA label property. And because we have some data here, I can get pretty descriptive with what my ARIA label should include. So I can say something like this is a die with a value of, and I can stick in some variables here. We'll say props.value. And I think it especially would be helpful to know whether it is being held or not. And so I could add in a ternary here that says, let's check the isHeld property. Oh, and it looks like I used the wrong curly brace here. And if it's being held, then we can say it's actually going to read out the word held, but otherwise it's going to read out not held. So this is already a huge improvement. It's probably the lowest hanging fruit for improving the accessibility in our Tenzies app. Something that is very similar and related, but also can be really helpful to include is a property called ARIA pressed. This is a way to indicate to assistive technologies whether or not this button, which is kind of acting like a checkbox or a toggle, is currently being selected or not. We're kind of covering that by including the term held or not held here, but this can also just be another easy thing to add, and we can simply give it the Boolean value of is held. The next thing we can do is make it a bit more obvious when the game has been won. Right now, we're really only indicating that the game has been won by dropping a bunch of confetti, but for those who might not be able to see that confetti or notice that the button text has changed from roll to new game, we can add what's called an ARIA live region. This is a section of our markup that, when changed, a screen reader will make sure to announce whatever content we put therein. And doing so doesn't even have to mess with the visual representation of our app normally. Let's come down to where we're conditionally rendering the confetti, and I'm going to include a div here, and I can include the ARIA live and set it equal to polite. Anything that I put inside of this div will get read out by a screen reader whenever the content therein changes, so I can conditionally render based on the value of game 1, maybe a paragraph that says something like, "Congratulations, you won, press new game to start again." Of course, by default, this will add a new paragraph to our page, which we may not want to do, and so we can actually include some CSS with a class name. Oftentimes it's called something like SR only, for screen reader only. And in our CSS, it will make it so that paragraph is never visible on the screen, but it will get read by assistive technologies. So I'm just pasting in here an SR only set of rules that I have copied from another project. It basically goes above and beyond to ensure that anything marked with SR only will never actually get displayed on the page. Now, at this point, there actually is one more accessibility improvement that I'd like to add, but it touches on something that you have learned in this course. And so I'm going to turn it into a challenge and give you a chance to look back at something we learned in section 4 and see if you can recall that information, or maybe go back and restudy it so that you can complete the next challenge. And we'll be doing all of this in the next scrim. I'll actually be truly impressed if you're able to do this challenge without referring to past material. So if you're feeling a bit lost as we talk about what this challenge requires, don't feel bad whatsoever, because it was something that we kind of just got a quick sneak peek on in section 4. But I do want you to give this your best shot. I want you to go back to section 4 if you need to review the lessons that we learned there, and then bring that knowledge back to this challenge to try and apply it. In cognitive science, recalling information like that and then applying it is one of the best things you can do to retain that information for the future. A quick change that I've made to our code just temporarily is when we're creating new dice, I just gave it a value of 5. That way we don't have to keep playing the game whenever we want to test the end scenario. I probably should have done that a bit sooner, but if we take a close look, I can hold all of the dice, and when I hold the last one, we can see that the button focus is actually here way on the first button in our list. For a keyboard user, that means in order to access the new game button way down here, I have to hit tab about 10 times just to get down to that button before I can hit spacebar or enter to trigger the new game button. Definitely not ideal. So our challenge is to make it so that when the game is over, the new game button automatically receives keyboard focus so that keyboard users can easily trigger it without having to tab through all the dice first. The code we need to add to make this work is not that extensive, but I did want to give you 2 major hints to help guide us along the way. The first one is that focusing a DOM element with the .focus method, which exists on DOM nodes, requires accessing a native DOM node. I want you to think back to section 4. What tool have we learned about that allows us to do that? Then, in order to automatically call the .focus method on a DOM element when the game is won, requires us to synchronize this local game1 value, or variable, with an external system, which is the DOM. So think again, what tool have we learned about in the past that allows us to synchronize React with an external system? The answer to these 2 questions is hopefully going to guide you in the right direction to solving this challenge. Again, if this is feeling pretty over your head, that's okay. You can click this Mario box to get a power-up, which will take you back to the lesson where we learned about the answer to number 1, and then the next lesson in that same course will lead you to the answer to number 2, and hopefully give you the tools you need to come back here to solve this challenge. So without further ado, I will hand it over to you to work on this challenge. In React, the preferred way to access a DOM node is by using a ref. We can create a ref by pulling in the useRef hook and then simply calling useRef. Usually we will initialize it with null if we're using it to access a DOM node, and we'll save it as a variable, which let's call it buttonRef. At its core, refs allow us to save values between the render cycles without actually triggering a re-render itself. Many times this ends up being used to access a DOM node from the markup that gets returned from our component. With this button ref, I can use a dedicated property on all React elements, like this lowercase b button, called ref, and I can set my button ref on this button. By doing this, when React renders these elements, it's going to set button ref equal to this DOM node, which I can then call methods like .focus on. As a reminder, I can come up here and console log my button ref. We'll see that at first it ends up as an object with a current property whose value is null, and that's because we initialized it with null. But then after it rendered the button down here, it set it equal to something different. We're just not seeing that in the console log. If I click one of these, then it triggers a re-render of our component, and this console log runs again, now with the correct value of button ref, which again is an object with a current property whose value is the DOM node of that button. Scrimba makes it look like it's kind of a JSX element or something, but that's just a simple representation of the actual DOM node. Okay, so with hint number 2, I want to automatically call .focus on my button ref.current only when the game1 variable is true. And in this case, we need to synchronize our local game1 variable with the DOM by manually, imperatively calling the .focus method on that button. So what tool do we have that allows us to synchronize our local React stuff with an external system like the DOM? Well, that tool is useEffect. And so I'm going to pull in useEffect. Let's get rid of this console log here. And at this point, I can get rid of my challenge text. And below game1, because I'm going to need to add game1 as an item in my dependency array, I need to make sure I do it after we define it. I can call useEffect, and I'll pass the first parameter, which is my callback function. And before I forget, my second parameter, which is the dependencies array that looks at game1. This way, this effect will only run on the very first time that the component renders, and then again if game1 ever changes. This gives us an opportunity to check if the game is won. Then we can simply call buttonRef.current, that's the property we have to access in order to actually get to the DOM node, and then .focus. Let's see how we do. We'll hit save. I'm going to just select all of these 5s. And when I click the last one, our new game button gets focused, so all I have to do is hit spacebar and we get a new game. This is a much better experience for any of our keyboard users. And a benefit for me, the teacher, was a great opportunity to review some of the topics that we learned in the last section. This has been an awesome project, and now we have finally rounded out the last features. Since we're here at the end of this project and near the end of this section, this is a great time for you to maybe do a little bit of a self-assessment. Look back at all of the code that we've written in this project and think to yourself, is this something that you could write by yourself if you needed to? I, as an instructor, can only do so much to request of you to do all of these challenges by yourself without just letting me hold your hand through them. And in your self-assessment, if you feel like maybe you could have done a better job, then there's absolutely no problem with going back to the beginning of this section, looking at that blank screen that asks you to spin up a brand new React app, and seeing if you can do the series of challenges again. If you really want to be a crazy person, you could simply highlight everything and hit delete and try to build it again from scratch. Things like this terrify me personally, but I know some people really thrive on challenges like that. Before I have a panic attack, let me Command-C that and get all of my code back. Oh, and I can't leave it like this, where our game is basically useless with this automatic 5 number being put in every one of our dice. All right, that's better. Congratulations on making it this far. It truly is a major accomplishment. I hope that you're feeling proud of yourselves, and I hope that you can find a great way to celebrate this win. Forgive the pun, but you, my friend, are on a serious roll. What a great job you did on that significant series of challenges. And what a fun project to build. This is one of those projects that I can bring my kids in and have them play, and they actually have fun playing it. It is so rewarding to build something like this that other people can enjoy. And the fun doesn't have to stop here. I have a few extra credit ideas that you can roll with if you want. For one, you could try adding a timer and or a roll counter to see how quickly you can win the game or in how few rolls you could win the game. You could style the dice so that they actually look like real dice with pips instead of numbers. And you could deploy your project live so that others can play on their own machines. The possibilities are endless, but one thing that I do want to make sure you do is to head over to the Today I Did channel in the Scrimba Discord community. There's really no better place to celebrate with others that are also working on similar improvements and content as you. And it doesn't have to stop there. Feel free to share it on your LinkedIn or your X accounts. If you're planning on looking for your first job in tech, then there's no better way than to engage with the communities that are around you. Once you've had a chance to celebrate for a little bit, remember that the job isn't done. We have one more really awesome capstone project in this course, and so that's what we'll be gearing up for next.